Hello everyone, welcome to my Your Programming Club. Today we will be solving another daily lead code problem, and the problem's name is height checker. So the problem statement goes like this. A school is trying to take an annual photo of all the students. The students are asked to stand in a single line in non-decreasing order by their heights. Okay, and let this ordering be represented by an integer array expected. Okay, so expected is the expected ordering of array representing the expected ordering of their heights, which is non-decreasing order, or you can say ascending order. Okay, so where each entry in the expected array is the height of the ith student in the line. Okay, so you are given an integer array heights representing the current order of the students that they are standing in. Okay, so it is not exactly the expected array, or it may be expected array. You have each heights, similarly as in expected array, is representing the height of the ith student, and you have to return the number of indices where the heights array entry is not equal to the expected array entry. Okay, so for example, if this is the heights array that is given to you, okay, so your expected array will be this, and you can see that these are the instances where heights of the expected array at the same index in the heights array are not matching. Okay, so 1 and 3 are not matching, 3 and 4 are not matching, 4 and 1 are not matching, rest all are matching. So you have to return the number of mismatches. Okay, or the number of indices where this condition happens, that heights I is not equal to the expected I, or the ith index of the heights array is not equal to the ith index of expected array. So this you have to return this count. Okay, so here the count was 3, so we returned 3. So let's have a look at the constraints also before thinking of an approach. So the height of the array will be of order 100, and each entry will be of order 100. So the constraints here are pretty low, you know so we need not to worry about that much about the constraints at least. So let's try to think of an approach. So what we one way of doing it is, we will form the expected array. So you are given the heights array. What you will do, you will form copy of heights array. Okay, and then you will sort this copy out. Okay, apply some sorting algorithm, and then you will get your expected array. Okay, once you have got your expected array, then you will just do a linear traversal of from indices 0 to size of, let's say the size of heights array is given to be size from 0 to size minus 1. You will change your indices, let's call this index, and whenever the condition that heights index is not equal to expected index, whenever this condition holds true, you will increment a counter. You will keep a counter, let's say this mismatch count. Okay, initialize to 0. Then whenever this condition holds true, you will increment the mismatch count, and at last you will return it. Okay, so if we talk about the time complexity wise, because of use of sorting here, if you are using the inbuilt function, generally it will take you, n log n, where n is the size of the given heights array. Space complexity wise, as you must have guessed, that because we have made a copy of expected heights array, to form the expected array, so we are using extra space of n, where n is the size of the heights array. Okay, so these will be the complexities, although you can use some sorting algorithms that will give you time complexity less than this one. But since the constraints are here not that much large, you can say, or that much strict, so that's why it's it will be a overkill if you are trying to optimize it even down the line. So one of the approaches that I could think of is counting sort. Okay, so what you can do is you can find out the minimum and maximum ranges, minimum value in the heights array and the maximum value in the heights array. Okay, and then starting from the minimum value going down towards the maximum value, you can apply, just a second, I don't know why the board crashed. Let me get this slide back that we were using. I think it is gone for now, so we cannot use it. Anyways, I hope you got the point, you know. So the entire point was that if you are using some counting sort type of algorithm, then you will be having a minimum value, and then you can have a maximum value, and you can use some frequency sort of thing. And I think it is not worth while discussing counting sort, but this is kind of a homework for you. If you are not familiar with counting sort, try googling it, and try to implement it on your own. If you are not able to do so, I will happily provide you the implementation. And yeah, this is the approach. And then if you talk about the implementation, let's have a quick look at the implementation also. Okay, so let me bring the code to the board. So this is the code. Okay, so first of all, you will be given the heights array as your input. Okay, and then once you are having this heights array, you will form the copy of the heights array, and then you will sort that one of these arrays to make the expected array. Here I have sorted the heights array itself, so the copy will serve as the original array, and this will be your expected array. Okay, and then you will compare these two, the sorted heights array and its copy, original copy. Whenever there is a mismatch, you will increment the mismatch count, and at last you will return it. Okay, so as I discussed, time complexity wise it will be n log n, where n is the size of the heights array. Okay, and space complexity wise, since we have formed a copy, so it will be order of n. Okay, these will be the complexities. This is the approach. So I hope you are able to understand. If you are still having any kind of doubts or any queries in general, then you may ask them in the comment section. I hope this solution walkthrough added some value to your DSA journey of honing your DSA skills. I will see you in the next video. Till then, keep practicing and keep solving problems. Thank you for watching.